Hi everyone, this is Pierre Prandi from CLS, and this contribution to the Polar Science Week is about combining multiple satellite radar altimeters to improve the resolution of sea level maps in the Arctic Ocean. So trying to get sea level in the Arctic has a quite long history, and the characteristic of all currently available datasets is that they are limited to the large scale and monthly frequency resolutions because observations are not, there are not enough observations in the Arctic Ocean to retrieve the small scale ocean circulation features. Here is an example of the CPOM dynamic ocean topography dataset by Tom Armitage and colleagues in 2016. So the question here is, can we improve the Arctic sea level maps? And one way to do that is to combine several other altimeters together. So all that datasets basically share the same processing strategy, which relies on the identification of the leads in the ice pack. So here this is done using a brand new neural network classification by Poisson and colleagues. Estimate the height of these leads. So here we use an adaptive retracker, which is able to provide a processing continuity from the open ocean to the ice-covered areas. Standard correction and editing procedures are applied, and what I'm going to focus here is on the gridding process, which is here based on an optimal interpolation under several assumptions regarding signal variance and covariance scales. So here's a typical one-day sea level observation sampling, and this is from one radar altimeter only, but there are several at the moment, so you can combine and increase the sampling of the Arctic Ocean. And through a merging algorithm, we're able to get a map, which is shown here, and that clearly has some more fine-scale features than previously available products. Of course, there's always the questions as if, are these fine-scale structures a true measurement of the ocean variability, of some artifact of measurement error? So here's a comparison at the Prudhoe Bay tide gauge in Alaska. The black line is the tide gauge measurements of sea level, and the here 3 colored lines are 3 monomission products that would have a low resolution, so typically 1 month and several hundred of kilometers in spatial resolution. And combining those 3 missions, we are able to get the red curve from the combined product, and clearly the red curve has more skill at following the small temporal scale resolution features of the tide gauge than any of the 3 monomission products. So at the moment, we provide 4 sea level products. 3 are based on the analysis of 1 mission only for Cryosat-2, Altica, and Sentinel-3A, and 1 is derived from the combination of all 3 missions. So the latter is only available over 2 years, because this is the only period we have processed Sentinel-3A at the moment. But a 1-year extension is planned. Those products are all gridded, and they cover, as far as possible, all latitudes greater than 50 degrees north. All the products are freely available from the Aviso website, and there's a link that will get you there. And if you have any problem or question or feedback or even interest in the project, feel free to download it, and please send me an email to send me an email so that I can get a grasp of what you're doing with the product, and any feedbacks are welcome to identify remaining errors and ways of improving the product. Thank you all very much.